This is Lesson 7, the first part of Lesson 7, I should say, in Precalculus, Graphs of Polynomials, coming from Section 2.2 in the College Algebra textbook. We look first of all at the definition of a polynomial. A polynomial function is a function of the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus terms in between up to plus a sub 2x squared plus a sub 1x plus a naught, where a naught through a sub n are real numbers. In other words, we have coefficients that are real numbers, and n is a non-negative integer, meaning that we have exponents on our x's that are non-negative integers. The domain of a polynomial function is all real numbers, as we've already discussed in this course. Which of the following functions are polynomials? We start with f of x equals 4x to the fourth plus 9 minus 13x squared. This is a polynomial. We're more used to seeing polynomials that are written in descending order, but we can just change the order here into 4x to the fourth minus 13x squared plus 9. The only thing that looks a little off possibly is that we're missing a couple terms here. We're missing an x cubed term and we're missing an x term. Well, you can imagine those terms as existing in spirit, just with zero coefficients possibly. So f of x is a polynomial. Now we look at g of x, which is equal to 2x squared plus 7 times the square root of x plus 2/3. If I rewrite g of x as 2x squared plus 7 times x raised to the power of 1/2 plus 2/3, you can see that we have a problem here. The power of 1/2 on the x is not an integer, so g of x would not be a polynomial. And now h of x, which is 3x cubed plus pi x minus 2 over x. We rewrite h of x as 3x cubed plus pi x minus 2 times x raised to the power of negative 1. Well, negative 1 here is not non-negative, so we have an issue with the exponent on x here, and so this would not be a polynomial. What you might see first off that might make you think we have a problem is the pi, where in actuality pi is not a problem because pi is a real number, so it's perfectly fine to have a polynomial with pi as a coefficient. Let's go on to look at some characteristics of polynomials: degree, leading term, leading coefficient, and constant term. Here I have f of x equals 4x to the fifth plus 9x to the fourth minus 13x squared plus x minus 7. If we look at the degree of f of x, the degree is the highest power of the variable, which you can see here would be 5. The leading term of f of x is a sub n x to the n, the term containing the highest power of the variable. Well, the highest power of the variable is 5, so the term containing that power of 5 would be 4x to the fifth. Then the leading coefficient is the coefficient of the leading term. Here we can see that would be 4. And finally, the constant term is the term with no variable. So at the end here we have minus 7, which would be plus a negative 7. So the constant term here is negative 7. Now, g of x equals 2. Well, this doesn't look like polynomials that we're used to, but it is indeed a polynomial. If you think of this as being 2 times x raised to the power of 0, then if we look at the degree would be 0. The leading term, there's only one term, and that would happen to be 2, so 2 is the leading term. The leading coefficient, again, we can think of as being 2. And then when we're asked for the constant term, well, 2 is a constant, so 2 would also be the constant term here. If we look at h of x equals negative 3x times 2x plus 3 cubed times x minus 2 squared, and we try to find the leading term and the constant term here, well, let's see what we need to do first that might help us think this through. I'm going to just write negative 3x as negative 3x plus 0 raised to the power of 1, and then I think it'll make a little more apparent how we go about finding the leading term. So to find the leading term here, we're going to take, we have basically 3 binomials, and in each of those binomials we have a leading term. So if we take the leading term in each of those 3 binomials raised to the power that the binomial is raised to. So we have negative 3x raised to the power 1, we have 2x raised to the power 3, and we have x raised to the power 2. This will give us our leading term, which we'll verify in just a couple minutes here. But we would then simplify. We'd have negative 3x times 2 cubed, which would be 8 times x cubed times x squared. Simplifying, we get negative 24 x to the 6th, and this is our leading term. Now, what about degree? Well, the leading term gives us a degree of 6 and a leading coefficient of negative 24. The constant term here, we kind of do the same thing. So let me go back up here and erase what we did earlier. Whoa, that's not going to work. Okay, let's try that again. Okay, we'll try to kind of clean up here, and then I'll show you how we get that constant term. So again, we're taking our three binomials here, 3x plus 0. The constant term on 3x plus 0 is 0. The constant term on 2x plus 3 is 3. And the constant term on x minus 2 is negative 2. We raise each of these constant terms to the associated power here. So we're going to have 0 raised to the first power, 3 raised to the third power, negative 2 raised to the second power. Then simplify. Well, 0 times anything is going to just be 0. So we do have a constant term of 0 here. Let's verify in the next slide here that we have indeed found the correct leading term and constant term. So here's our polynomial, h of x, and if we expand this polynomial, the terms in this polynomial, we have 2x plus 3 cubed, which is 2x plus 3 times 2x plus 3 times 2x plus 3. We have x minus 2 squared, which is x minus 2 times x minus 2. I start by multiplying 2x plus 3 times 2x plus 3 and x minus 2 times x minus 2. And here we have the result. And next I'm going to take 2x plus 3 times 4x squared plus 12x plus 9. Our expression here is getting a little more complicated looking. And so I will next, I'm not going to show all the steps here. You can try this on your own, but I'm going to take the result of 2x plus 3 cubed times the result of x minus 2 squared. And then we get this kind of ugly looking thing here. And finally, to make it more ugly, we'll distribute negative 3x through to end up with h of x equals negative 24x to the 6th as our highest power term, indeed the leading term, plus a bunch of stuff in between, plus 0, our constant term on the end. So we verified that what we were doing before did actually work. Now, try on your own. Find the leading term and the constant term of the polynomial p of x equals 3x minus 1 times 2x plus 3 squared times x plus 2 cubed.